Okay. Welcome, guys, once again to our cloud lectures. Today we'll be following up with our lecture from last week. So we'll be doing networking part 2. So in this part, we'll be focused on discussing networking in the context of AWS. So last week we just discussed networking in general. And today, as you can see from the screen, we'll be discussing topics like VPCs and subnets, internet gateways. We'll also go look at security group, network ACLs, VPC flow logs, VPC endpoints, and also we'll look at how to connect our on-premise network to the cloud. So let's dive right in. Yeah. So the question is now, what is a VPC in reality? So the virtual private network, the private cloud, often abbreviated VPC, is essentially a private virtual network inside of the AWS network. So AWS offers this service whereby you can create your own network within their own network. And when you create this virtual private virtual network, or to say, it's referred to as a VPC. So while AWS is a shared network, the network that supports this is a physical shared network. What you're actually creating is just a logical partition, as we saw in last week of networks can be the network can be a connection of several networks, but so AWS allows you to create a logical partition within their own network, and all of these VPCs will be isolated from each other unless otherwise you maybe actively or intentionally connect them. Now, when you have created a VPC when you have a VPC within the AWS network, that is and you create resources, or for example, you deploy a virtual machine, or you create a database instance. These are created within your own VPC, within the particular VPC that you've chosen to create them. So as a customer to AWS, every resource that you create or you deploy is created within a VPC of your choosing, and that VPC belongs to you. It's not shared with other customers unless you share them, of course, or grant them access to it. But intrinsically, every resource, everything you do in AWS, you do it within a VPC that belongs to you. And as we also saw last week about private virtual networks, they all come with a primary CIDR block. Every VPC comes with a CIDR block, and in the case of AWS, these virtual private networks have what we call a primary CIDR block and what we call secondary CIDR blocks. So you can have one primary CIDR block and up to 4 secondary CIDR blocks. And just as a reminder for those who might not be here, a CIDR block is a range of IP addresses to which resources or instances within this VPC would get their IP from that range. So IP addresses of, say, example, virtual machine within your VPC would be IP addresses that are found in the range provided by this primary CIDR block. You also in AWS, you don't just have they also divide your VPC into 2 types. There's the default VPC and there's what is called custom VPC. So you remember AWS network is divided also into regions, and so when you create an account in AWS, you get a default VPC in each of these regions. So, but a custom VPC is a VPC that you create by yourself. The default VPC is created already every region when you create an account in AWS. But you can go ahead and create multiple VPCs in each region. Yeah. So I show a diagram here to express what I just said. So again, as emphasis, a VPC is a regional resource. So as I said earlier, a VPC is created within a region, so it does not span across several regions within AWS, several AWS regions. So I've shown you on the diagram, AF South, this is Africa South. This is the region of AWS whose data center is located in South Africa. And I've shown, for example, a customer A has his default VPC in this region, and also have a default, he would have a default VPC in every region, but he has created a VPC or VPC1 in this same region, Africa South, and he has created two VPCs in another region called EU West and EU West 1. So if you will not see what I'm saying, so the diagram is divided into two regions, and VPC2 and VPC3 are in the region EU West 1, and the default VPC is demonstrated only for AF South region, and VPC1 is shown to be created within AF South region, and you can see that every VPC comes with a separate CIDR block. So before I go ahead into other topics, if somebody have a question, you can raise it now also. Okay, well, if there's no question, I would go ahead, but you can bring me back to this topic if you want. Yeah. So let's discuss some of the components of VPC. The first main component of a VPC is what we call subnet. We've already seen subnetting in our private networks topic last week. So again, a subnet allows you to create a partition within your network. In this case, you have VPC. In this case, you have VPC. And the subnet in AWS belongs to exactly what is called an availability zone. So just like the VPC cannot span multiple regions, a subnet cannot span multiple availability zones. Subnets also have their own CIDR blocks, and these CIDR blocks it can at most be the same as the CIDR block of the VPC in the case where you have just one subnet within the VPC, or the subnet can be a subset. The CIDR block of the subnet can be a subset of the CIDR block from the VPC. Usually you have your CIDR block in IP version 4 and IP version 6 are available, but you can also restrict your VPC to just IP version 4. But this is not possible for IP version 6, to restrict only to IP version 6. And so if your VPC has IP version 6 enabled, then your subnet can also have IP version 6 CIDR block. So again, there are also two types of subnets. We have the public and the private subnet, just like we had networking before. In this case, the public subnet is just one that have addresses that are accessible from the internet, and the private subnet is one that is not accessible from the internet directly. So remember, all of these still stay within an availability zone. Now, when communication between subnets, for example, and the internet happens, the VPC uses what is called route tables. We'll see more about route tables in the subsequent topics. But just as a reminder, a VPC is a zonal resources like EC2 instances are created within an availability zone, and of course within a subnet. So again, I show another representation of this. So you have for example, an EC2 instance in all the subnets and a private subnet as well as a public subnet, all isolated to within an availability zone. And I also show you again the VPC for customer A is spanning several availability zones, but it stays within a particular region. Okay. So yeah, that's also again about subnet. If you have a question, you can ask now.
Theo, I think I can just add that just a big reminder back for everyone. Remember when the topic of global infrastructure was covered, right?
Yeah.
You had what is called regional. The AWS is divided. You always have the regions, sorry, and then you always have availability zones. And a region is made up of 2 or more availability zones. If everyone should remember that. So, and you remember again that we said that when you study a service in AWS, you should always ask yourself whether it's regional, zonal, or global. Global will mean it covers the whole AWS worldwide. I think that's easier. Regional will mean that it covers just one region. So regions in AWS is you have names as AF sub-1 and when you are creating them. So bearing in mind that a VPC is a regional service. So when you create a VPC, it will cover an entire region. And since regions have availability zones, that's why you see that one big, when you create one VPC, it has one CIDR block, which is the network for that VPC, the entire network for that VPC. And then now, since a VPC is made up of, since a region is made up of different availability zones, you can then now take that one CIDR block, which is one big address, and then subnet it as we studied in the last session. And then each subnet will then belong to one availability zone. And then you can go further ahead to make that each of that subnet to be either public, and public will just mean that it has access to the internet, or it will be private, which means it doesn't have access to the internet. So just trying to go back with global infrastructure and availability zones so that everyone can remember how that fits in. Yeah, that's just what I can add. And I hope if there are questions, please feel free to ask. And and try to find time to look more into this again. Yeah, Theo,
okay, thank you, Dr. Yeah. So yes, as you're saying, these CIDR blocks and CIDR and subnets all come from the VPC. So sorry. So again, down bottom left here, you can see the VPC CIDR block, and the other ones are exactly broken, taken out of that CIDR block. So yeah, if you have no questions. Oh, again, okay, yeah.
Hello.
Yeah, go ahead.
Yeah, good morning, sir.
Yeah.
From what Mr. Barnes said, that the private, the public subnet is accessible by the public, and the private is not accessible. I wanted to find out, is the activities in cloud not connected with internet? Because when I say it's not accessible
from the internet.
From the internet, I don't. That part is a bit is making me confused.
Yeah. So activities in the cloud are accessible from the internet, but when we talk about being as the VPC subnet being accessible from the internet, it means, let's say you provide a resource. Let's say you create a web server and you place it in your private subnet. People cannot initiate connection like by typing maybe www.WirfonCloud for example.com, and if it is in the private subnet, they cannot initiate connection to that server to get the web pages to be displayed. But if it is in a public subnet, then that is possible. Again, but as the owner of the server, of course, you can go to the server within the subnet, within the private subnet, and do configurations there. But initiating a connection to it over the internet, when it is in a private subnet, is not possible. This is to protect your resources. So, for example, if you have a database, for example, on which your application web server is running, a web application is running, you place your web application on a public subnet so that it can be accessible from the internet by your users. With your database, your users don't need direct access to that application. So you place it in a private subnet, and your users don't need direct access to your database. So you place your database in the private subnet and allow connection to it just from within the public subnet, that is from the application in the public subnet. So I don't know if that clarifies the difference between being able to access it as the owner and having access to it from the internet as a general user.
Yeah, it does. Thank you, sir.
Thank you very much for your question also. Does any other person have a question or a doubt on the answer for the question? Okay, so let's go ahead. So another component of VPCs that we saw is called routing tables, and so these routing tables are used for routing and for requests within or outside the VPC. So all your VPCs effectively come with a router. So something that decides where request is going to by looking at the routing tables. So this virtual router directs your traffic to its ultimate destination. Now, the routing table contains what is called rules, and these rules tell the destination is what the router uses to read what the destination for a particular traffic is. So, and then it forwards the router forwards this decision based on what is in the routing table. Okay, you can also have so you can have a VPC routing table specifying that a route goes is destined for resources within the VPC, and every VPC comes with its own a default route table. You can now add many other routes to this default route table, or the route. It also has a default route, and you can add more routes to this route table. Now, also remember that the route table is for a specific CIDR block. So if your VPC has one or more CIDR block, then you also have multiple route tables that you have to specify. Yeah. So I have shown an example here. This route table is showing that a request destined for this CIDR block 10.0.0.0/16 means it is local. So the request should be routed within the VPC, and a request destined for this again is 0.0.0/0 should be sent to the internet gateway. We'll see more about internet gateway subsequently, but this indirectly is what the VPC uses to reach out to the internet. Now, the route for the routing table is processed in the order of the most specific to the least specific. So again, if you ask yourself, how do we know now for something that is maybe in this range, in the top range, but also part of this second range? What we know here is that the routing table starts with the most specific, and therefore when any matches, it routes to that target destination. So that's how it decides when there are conflicts. The least the most specific is the one that is chosen when there are multiple options. Yeah. Now, so the routers decided build a map for your network, and so does every destination is specified in the route table, and so when traffic is destined for another router, of course it is sent to that router, and the router would decide from there how it will forward the package to the ultimate destination. Yeah. So we also have what is called internet gateway, as we just saw on the route table. So an internet gateway is basically a type of resource that within the VPC that provides a target for your VPC routes that are going to the internet, and it helps to perform network address translation as well for your instances that have been assigned public IP addresses. So specifically those instances that are in the public subnet, and so they connect directly to the internet gateway and to send requests to the outside to destination that are outside of the VPC. And then yeah, the internet gateway support IP version 4 and IP version 6 traffic as well. So, and AWS claims that this does not cause an availability risk because there's just one internet gateway for the VPC. So, because it is horizontally scaled and also redundant and highly available component of your VPC, you can rely on it for to not become a bottleneck. So there's no additional charge also for having an internet gateway in your VPC. Yeah. Okay. So now you also have what is called a NAT gateway. So sometimes you might hear of a NAT instance. This is just a self-managed NAT gateway. So a NAT gateway is managed by AWS itself, and you can use this also for address translation. But this is what is the purpose of a NAT gateway? The point of a NAT gateway is that you create a NAT gateway within an AWS public subnet and allow your instances within the private subnet to connect to this NAT gateway if they want to communicate to the internet. So they initiate communication to the internet by first going through the NAT gateway in the public subnet, and then communicating to the and then from there it goes through the internet gateway, which is used for that VPC, and for their communication is then forwarded to the internet. But you cannot initiate communication through this NAT gateway into that private instance. So of course, responses to requests from the internet are returned to the instance, but you cannot initially make a request to that instance in a private subnet going through this NAT gateway. So you are charged for having a NAT gateway in your public subnet, and the charging is an hourly based usage. You must, yeah. So NAT gateway are not supported for IP version 6 traffic, and they use only outbound. You have to use outbound egress, or also called egress on the internet gateway instead. So that's an alternative for NAT gateway when you are using IP version 6. So I've shown here again. So the NAT gateway is located in the public subnet, and the instances in the private subnet connect to the NAT gateway in order to talk to the internet through the internet gateway, abbreviated as IGW. Here NAT gateway is just NAT. Both of the perform address translation, network address translation, and for instances in the public subnet, when they need to connect to the internet or talk to the internet, they directly go to the internet gateway. Yeah. Okay, so that is it for NAT gateways and internet gateway. If you have a question, maybe we can hear it now. Okay. So let's look at network access control lists. So as we have talked about components within your VPC, and we've looked at possible things that you can place in your VPC apart from the instances and resources that you create there. So, but how do you protect these resources from your VPC within your VPC or within your subnet? So, NACLs or network access control list is another optional layer of security that you place on your subnet as a firewall for controlling both inbound and outbound traffic from at the level of your subnet. You can add rules. So these knuckles are a set of rules that you can add on the default knuckle. So you also have what is a default knuckle for each subnet that you have, and you can add additional rules to this knuckle. When you add or remove rules from the network access control list, these changes also are applied automatically to the subnet. Yeah. So, knuckles allow or deny specific inbound or outbound traffic at the level of the subnet, but you can also so you as I said earlier, when you create your VPC, you have a default knuckle already there, so you can add this this rule to the default knuckle, or you can create a custom knuckle by yourself for your VPC. Each network includes a default rule, so the knuckles are numbered. The rules in your knuckle are numbered, but each network contains a default rule whose number is an asterisk, as you can see on the diagram. This rule ensures that if a packet does not match any of the rules that are specified in the knuckle, then the packet is denied access. So that it is not allowed to go in or to go out, because there's no rule that specifies that it is allowed or denied. So the rule, the star rule, is immediately applied, and it is so you can see that for any protocol or any port and any type of traffic source, it is saying deny. And but again, you can see that all the rules have numbers, and the knuckles are evaluated from the smallest number to the highest number. So you can consider this star rule as being the highest number or the last rule that is evaluated, which means that for any traffic, if we've not found anyone that matches the previous rules, then we perform a deny on them. So again, we have both outbound rules and we also have inbound rules in all our VPCs. So that again, you'll see more. We'll compare also knuckles with what is called security group subsequently, and we'll know the difference between when the rules are applied outbound here and when it is inbound rules here. Yeah. So again, the knuckle is attached at the level of the subnet, and so each subnet comes with its own knuckle, or you can create multiple. And after a request leaves the knuckle leaves the subnet, it is evaluated at the level of the knuckle network access control list before being sent to the router, which would maybe then forward it to the internet gateway if it is in the public, if these are public subnet. Okay, so you can see that yeah, so each knuckle determines which traffic is allowed or to leave or to enter the subnet to which it is attached to. And even so, I just talk about traffic leaving and going towards the internet gateway. This is the same for traffic coming. in from the internet gateway going through the router. It also has to be evaluated at the level of the NACL before being allowed into the subnet for private for public subnet also. Yeah, if the connection was initiated from outside, of course it must be a public subnet. Yeah. We also have what is called security groups as part of our VPC components. It also acts as a firewall to control access to your VPC, but no, not to your VPC, to instances or resources within your subnet. So security groups are not attached to the subnet level or VPC, but they are attached to particular resources within the subnet. So for example, each EC2 instance in your subnet would have a security group assigned to it. You can assign multiple security groups to an instance. Each of these security groups would have rules that are evaluated before allowing traffic in to reach the instance or to leave the instance. Yeah, so yeah. And again, one important aspect of security groups is that they are stateful. So that means that let's talk about a public subnet, for example, an instance within a public subnet, for example, maybe one that is hosting your web server. It's so stateful means that if a request is allowed in, then the response to that request is allowed to go out of the instance, irrespective of whether there's a rule saying this kind of traffic is allowed or not allowed. So out. So unlike NACLs, where if you allow traffic in, you have to specifically say this traffic should be allowed to also go out. Security groups more or less say if you allow traffic for, say, a particular protocol, an example, HTTP traffic, to go into your web server, then if somebody makes a request to your web server over the HTTP protocol, the response to that request should be allowed to go in and go out, even if there's no rule saying allow HTTP protocol to that particular destination to go out. As long as there was a rule saying allow it to come in, then there's automatically the option to say allow it to go out. So in that sense, we describe the security groups as being stateful, but for NACLs, we describe them as being stateless. We'll see more on that also when we compare NACLs and security groups. But at this moment, let's look at how, again, this diagram demonstrates. So you have instances in your VPC, in your subnet, and yeah, these sub instances are connected to some security group. So multiple instances can be connected to a single security group, or an instance could be connected to a separate security group. Instances could be connected to separate security groups. And after the security group, you again have the network access control list, which are there to evaluate traffic into the subnet before it is traffic in or out of the subnet, before it reaches the security groups, or after it leaves the subnet, the instances from the security group to the network access control list. And yeah, you see you have your internet gateway up here and your router either routes traffic coming from the subnet to the internet gateway, or route traffic coming from the internet gateway into the to the route table, using the route table to the particular subnet, and which is first then also goes through the NACL before the particular security group that of the instance that is protected by of the instance that security group protects. So yeah, this is kind of a summary of how you can picture where the NACLs are located, as well as where the security groups are located in your VPC framework. Yeah. So again, let's look, we've heard about rules for securing our resources within our VPC, rules coming both from security groups as well as from NACL. Maybe it's good to also compare the two. So you can see the first one, which is already mentioned, that security groups rules operate at the instance level. So that is to say that you attach security group rules to your instance, as I have mentioned, but while the rules of NACL are attached at the subnet level. Again, security group rules allow okay. So again, because it is stateful, you only specify what is allowed for security groups. So you say, you go to a security group rule, you say this SSH, for example, is allowed into the instance, and it is then automatically implied that an SSH request would be allowed. If it is allowed to the instance, then there must be an exit one. But if it is not allowed, then there's no way to initiate that communication. But for security groups, that's for NACLs, rules have to be either specified as being allowed or denied. So you have the option to say a particular request from a particular source or to a particular destination is allowed or denied. And unlike for the security group, where you only say for a particular protocol and a particular destination or a particular source, this is allowed. You don't say it's denied. As I've also mentioned, security groups are stateful, but NACL group rules are stateless. Yeah, and for security group, we evaluate all rules before deciding to allow traffic. So all the rules in your security group would be evaluated when considering a traffic that is arriving the security group, or that is going, arriving the web instance or the particular resource that the security group protect. But in NACLs, the rules are processed from the smaller, the least in number, the smallest number to the highest number. And as soon as a rule that says this request is allowed or this request is denied is reached, is found, then the request is processed accordingly. And so higher rules are not processed. So NACLs process rules only as long as they have not found the one that matches that particular traffic. Again, security groups applies to an instance only if someone specified the security group when the instance or associated security group was created. Associated security group was created later on. But for NACLs, they apply to all instances in that subnet. So wherever traffic is going into that subnet, it has to be evaluated, applied on the NACL. But for instances in the subnet, the security groups are only so you can have security groups in your instance, in your subnet, as well as instances. But if those instances are not associated to that security group, then the security group would not be applied on that instance. And so a request coming or leaving the instance would not be checked by the security group. But if you have NACLs on your subnet, every instance or every resource within that subnet would have to, the NACL would have to be processed for any request leaving or going towards that instance in the subnet. Yeah. So before we go into VPC flow logs of using, maybe someone can ask a question if they have a question or add something.
Yeah, just one. Okay, go ahead, Edwin. Ask a question. That's okay. Come in with your question.
Yes, I just want to get something clear with the NACL and the allow and deny rules, as you said earlier. So can they be considered as, or do they perform the same functions as the JSON documents we saw for EC2 instances?
The
JSON documents, can you be specific on that?
Yeah, you know, we learned before that the JSON documents specify like the rules for that apply to an EC2 instance.
Okay, I think you are talking about when you are creating policies for
Policies,
access.
yes, right.
Yeah, okay. So those policies are when you as a user on AWS are trying to reach that EC2 instance, for example, in order to say, go into the instance and look at what is running in the instance, or maybe create some files within the instance, or do some activity manually, not over the internet, for example. So I'm not like some kind of traffic coming from. Yeah. So as a user, do you have access to this instance? Do you have access to no? Do you have access to modify this instance? Yeah. That's the first part I said was not correct. You're not going into the instance. You're modifying the instance. So, for example, an instance is created within some subnet, and it is allowed some public IP, and I want to remove this IP, or the instance is created and I want to delete this instance or terminate this instance. The JSON policy say, as a user of that account, I can, the policy allows me to make these modifications or deny this account for making these modifications on the instance. Security groups rules or NACL rules are about traffic going into the instance, like being processed by resources within the instance, or traffic leaving the instance. So traffic, for example, if a web server is running in your instance, the NACL is saying, if I do HTTP a request for my IP address, the NACL is saying, this is not allowed into this subnet, or the NACL is saying, this is allowed into this subnet. Even for a subnet, you have policies that allow, the users of an account may or may not be allowed to modify, say, the IP address range of a subnet. But that's about those policies. But when it comes to NACL, it is about traffic flowing through this subnet. Does that differentiate it for you?
Kind of. So basically, a JSON document tells you what permission you have to. The JSON policy tells you what permission you have to make changes on an EC2 instance.
Yes.
But a NACL gives permission for what traffic goes in and out of the subnet.
Of the subnet, or the security group determines what traffic goes in and or out into the instance, instance, not change the instance. Maybe if you want to change the size of the instance, the JSON policy controls that. If you want to look at what is running in the instance over HTTP or SSH, the security group controls that.
All right. Thank you very much.
Thank you too for your question. Thank you.
There's a question on the chat. I don't know if the question is
okay. Let me check. Yeah, if you want to read, you can read also. But
when you say NACL controls traffic, do you mean the cyber blocks that have been assigned to a particular instance?
So when I say NACL control traffic, yeah. So for example, an instance, not the cyber block is not assigned to an instance, it's assigned to a network, again, just to be clarified. But when I say NACL controls traffic, it means these rules. For example, I try to go again to some rules before I show some rules. Yeah, for example, so Yes, this stop rule. Can you see where I'm pointing the mouse? Is it possible?
Yeah.
Okay. So this stop rule is saying for all traffic, so be it HTTP, be it SSH, be it SMTP, all traffic. So of course all protocol and through any port 22, 80, 443, we can name them, coming from any source. So this 0.0.0 says any source. Allow the condition, the rule is to allow all the traffic. So it's saying this cyber block is not the cyber block of the subnet. It is the cyber block of that refers to which particular IP addresses are allowed, and in this case, it's saying all IPs. So let's say we have since this is NACL, we have an instance running in our subnet. This NACL is saying, and if this NACL instance is running, for example, a server, this NACL is saying for all traffic that is coming in, be it from any IP around the world. It could be Cameroon, it could be Nigeria, it could be South Africa, Asia, an Asian country, European, or whatever, because that IP address range in the source column, it's saying any IP address. If it is coming to this instance, the rule is saying allow it. If the person is trying to get into SSH, if the person is trying to go HTTP or HTTPS, the rule is saying allow it. And also the same for the rule below is saying for all instances in the subnet, this rule 100 below, this is an outbound rule. For all instances in the subnet, all resources in the subnet, if they try to connect to any IP in the internet, so if they try to connect to another server somewhere outside of the VPC, allow this traffic to get out of this subnet. We would maybe when we start going deeper into NACLs and their rules and how they are, how to write NACL rules, you will see how to be more specific, how to restrict rules, and how to specify the protocol, and which ports and port ranges and goes for which protocol. But for now, what I want to be more lay more emphasis on is that these are the particular components of each NACL. You have a type of the NACL which specifies the type of traffic, the protocol, you have a port range, or it could be a particular port, and you have for inbound traffic, you specify the source, and then what the rules should do, it could be allow or deny. And for outbound traffic, you have to specify a destination, what the rules should do for traffic going to that destination, whether it should also be allowed or denied. Does that help? So the cyber block of a network does not have a particular thing to do. Okay, so again, the cyber block of a network is only meaningful for the outbound rule, which says request comment. No, it's not. Okay, so the cyber block of the network has nothing to do with these rules, because these cyber blocks in the outbound rule and the destination are for things. So for the inbound rule, this is from something outside of the internet, and also for outbound rules, this is for something outside the internet. So it has nothing, it does not have anything to do with the cyber block of the subnet. These are separate cyber blocks. Hello, Sally. Does that help?
Somehow, yeah.
If it's not clear, you can maybe ask where it's not clear, and I can try to clarify it more.
Oh, do you mean that? Okay, so go ahead.
Yeah. Chair, please go to the next slide you had with the diagrams. The other one.
This one?
Right. No, the next one. I think on that you had the different
differences between.
No, where you had it, yeah, here, right? Okay, just to help again, so yeah, just based on your question, Sally, it was NACL controls traffic. So remember that a network control list with just explain that it's you can place it on at the subnet level, right? Because you always have one big CIDR block, right? Which is remember one big CIDR block for a network, and remember a CIDR block is one big network. And then when you subdivide them, you have subnets. Now, and then when you create those subnets, you can then create instances inside. Instances are always inside the subnet. So security in AWS is in different layers. The first layer affects the subnet. So if you notice in this diagram, network access control list is placed on subnet 1, right? So the NACL is placed at the subnet level. The security group is placed inside the instance level. So if you see the insecurity is inside. So the NACL is placed on the subnet, for example, on subnet 1. So that means that the NACL is controlling the traffic that has to pass through that subnet, because the subnet is a network on its own. Traffic has to pass through, has to be processed, as Theo explained, before it can get into any instance. So the NACL is sitting at the subnet level, right? So so when you say CIDR that have been assigned to that instance, yeah, CIDR blocks are not assigned to instances, they are assigned to the entire VPC, and then it's subdivided into, and the CIDR block is subdivided into subnets. And then when you send traffic and it's going through that subnet, you have a NACL that figures out whether it should allow this traffic or it should deny it. So it's like a firewall sitting to control what comes into that subnet or what goes out. I don't know if that helps as well.
Yeah. Okay, yeah.
Okay, if there's something more adds, and I know at times explaining this can be always a bit challenging for people to understand, but once like you start doing the practice session, right? You will start realizing, having that aha moment of how that comes about. But what I also wanted to emphasize on is for the differences between security groups and network access control lists, as Theo has in the diagram, is very important to understand which level the security group works, which level the network group works, as we mentioned, as Theo has explained that here, because those are some of the things that when you're thinking of the exam that always come up, knowing the differences between these two. Yeah. So, and it's all here. So make sure that everyone should make sure they cover that. And if you have questions, please feel free to ask again. Yeah. Okay, that's all, Theo. Yeah. I don't know if anyone still have a question here.
Okay, I guess if there's a question, we'll have it again later, but let's go on to VPC flow logs. We've seen about protecting traffic in the VPC, and we've seen about resources or components of our VPC. So one thing that is left again is about what happens to traffic that is going through our VPC, because we've already seen how to secure those, for example, our instances, create security layers and so forth. So VPC flow logs on AWS is a feature that enables you to be able to capture this information about the traffic going through your VPC. So you don't only secure instances from traffic or leaving or going into your VPC, but you can actually be able to capture this traffic and record it somewhere for the purpose of maybe analysis and so forth. So if maybe a request comes through your NACL and not through your internet gateway, and is going through your router, goes to your and it's evaluated at your subnet with the NACLs and also the security groups, and it's routed to a particular instance. All of these things, the NACL, the instance, the internet gateway, maybe if there was a load balancer or an application balancer, all of these things have IP addresses, and the traffic, they are recorded that this traffic went through this resource with this IP address, and it was forwarded to this resource with this IP address, and what kind of protocol was being used to reach to make this request. All of this is recorded, and you can store these logs in your S3 bucket, and they can also be used. They can then be used also for diagnosis or just for monitoring how much traffic is coming to your instance per second, and also to understand which resources in your VPC are having a lot of traffic going to them, or which resources have a lot of traffic leaving from those resources. So this is not a feature that is not enabled by default, but you can enable it to be able to understand how the service you're offering, for example, is being used by the public. So we also have what is called VPC peering. So yeah, you can go ahead, please. Does somebody have a question? Okay, I thought I had a question coming up. Okay, so another concept in the VPC is called VPC peering. So we already saw that VPCs are isolated from each other, and therefore there comes the question of, if I have instances, for example, in two separate VPCs and I want to connect them, how does this then work? So it is we can use, for example, what is known as VPC peering. So you connect these two VPCs, and some routing rules are created in their route tables during this peering connection, in such a way that a request destined from one VPC to another is then routed properly to that VPC by using these route rules that are added to the route tables. This then enables instances in different VPCs to be able to communicate with each other. And this is very useful for organizations that have several VPCs for each, maybe separate VPCs for each department. And there are some departments that needs to communicate with each other. Now, some very important thing to note is that VPC peering is not is a one-to-one relationship that does not support transitive peering. So this means that if a VPC is connected to one VPC, as I show here in the diagram, so if the default VPC is paired with the customer VPC 3, for example, for the peering, this VPC peering connection, and again, customer VPC 1 is also connected with VPC 3. This does not directly mean that the default VPC is paired with VPC 1. If you want the two of them to be able to communicate, then you also have to create a separate peering connection for that VPC. So it does not mean that this is not possible that I make a request and it goes, for example, through the peering connection of VPC, default VPC and VPC 3, and then go to VPC 1. This is not possible. There's no transitive relation in VPC peering. So for every VPC that needs to communicate with each other, that in your organization that needs to be able to communicate with each other, you have to create a peering VPC if you're going to use VPC peering. And you can begin to also see how cumbersome that might be if the number of VPCs grow. So we'll also see a solution to this problem. If you have several VPCs, you have now what is called a transitive gateway. AWS transitive gateway allows you to create some kind of a central hub for your networks. it also even allows you to connect not just VPCs in your cloud, in the AWS cloud, but you can even connect VPCs on your networks, on your on-premise location or on-premise data centers. So, and again, by default, of course, this is transitive peering being created. So every VPC that is connected to this central hub or to this central gateway is indirectly connected with each other. So again, it's also provides security for your data, as it is automatically being encrypted, and this data does not travel over the public internet. So if I need to connect the 3 VPCs, for example, I don't create connection between every pair of them. I can just create a transitive gateway and connect all the VPCs to that transitive gateway, and they would be automatically connected with each other. And for the VPCs that I do not want to connect to I do not want to peer, or I do not want them to be connected to other VPCs, I do not add them to the transitive gateway, or I do not connect them to the transitive gateway, as the case is for VPC 2. So if there's any doubt there, maybe I give another chance to ask questions about connecting VPCs. We've seen peering option, peering connection, and we've also seen transit gateway. Okay, there's no question. Then yeah, let's go to VPC endpoints. So when you also want to make use of resources in the AWS network, like for example, your S3 bucket is not created within a particular VPC. It's just in the cloud there, and your instance maybe want to use this S3 bucket. Then it doesn't necessarily have to go through the internet, as the default case might be, to access this S3 bucket. You can create what is called a VPC endpoint to make use of this. So this VPC endpoint enables communication between the instances in your VPC and AWS resources by going through what is called the AWS private link. So it's isolated from the internet, and therefore your communication between between instances in your VPC and your S3 bucket is also automatically protected from public access. Yeah, and indirectly, in this case, they are not even using public IP addresses anymore. It's using the instances can remain with private IP addresses, and this is very useful for the safety of your resources, because traffic is being protected not just by maybe encryption, but actually for a hacker, for example, to get access to this, they would have to be within that VPC to be able to connect to instances within the VPC, to be able to communicate with the private IP addresses or interact with these private IP addresses. So when you have a VPC endpoint, you don't need anymore the internet gateway to reach your S3 bucket. You don't need a NAT device or a NAT gateway for resources that are in the private subnet. Yeah. So now, another aspect of this is that, again, VPC endpoints, you might be tempted to see them as bottlenecks to your resources, but these are very scalable. They are highly available, so they can be relied upon to be always there. AWS guarantees this high availability. So if you're going to connect several instances to your S3 bucket through a VPC endpoint, you don't have to worry about bottlenecks. And yeah, And for those who are in doubt of what a virtual device is, it's just a program. We've seen already virtual machines or EC2 instances. So these are just programs that make the functionalities and features of a physical device. So in this case, we are now talking about VPC endpoints. So they are actually also virtual devices. You don't really, it's not a physical device that is created and connected to your VPC. It's also just another virtual device that provides this communication with the instances, with the resources outside your VPC. So there are several types of VPC endpoints also. We have what is called an interface endpoint. So in this case, it's an ANI, or what is called Elastic Network Interface. And it comes with a private IP address, of course, which is obtained. These are private IP addresses, just is one of the IP addresses supported by your subnet, and it serves as an entry point for traffic destined to AWS resource services or other or as we may call it, a VPC endpoint service. Again, as already emphasized, interface endpoints are powered by the AWS private link, so there's no communication over the internet. We also have what is called gateway endpoint. For gateway endpoint, the main difference here is just that they are supported just for S3 and DynamoDB. So if you want to connect to any AWS resource, or which is not an S3 bucket or a DynamoDB table, you would use the interface endpoint in general. And if it is an S3 bucket or a DynamoDB, it's best for you if you use the gateway endpoint. And these are always specific for this gateway endpoint. For this gateway endpoint, you always specify the routing table for traffic that is going to this gateway endpoint on your on the route table associated with your subnet, or your VPC. Sorry. So the gateway endpoint is attached to the VPC, not the subnet. So, and the route table that is used is the route table for your VPC. Yeah. So we also have, besides the interface and gateway endpoints, you have what is called also the gateway load balancer endpoint, and this is used when you want to use your load balancer together with for intercepting traffic and routing and route the service as configured for your load balancer. So you could be able to intercept this traffic and be able to make use of the information that is going through this gateway load balancer, and to be able to evaluate for security inspection, for example, or for other analysis purposes. In this case, you just at this particular point, you don't need the VPC flow logs if you're interested in this the traffic going at this point at the level of the load balancer. But if you do a VPC flow log, then you would know at every point of your VPC what kind of traffic is there. So I just put a diagram here to demonstrate again. So as a reminder, VPC endpoint gateway, you use S3, use it when you want to connect to S3 or DynamoDB. But for say CloudWatch and other type of AWS services, you should use the VPC VPC endpoint interface. And yeah, that is it for VPC endpoints. Let's look at connecting on-premises networks to the cloud. So again, by default, your instances launched in your Amazon VPC cannot communicate with your remote network, so your own data center or your corporate data center. but you need some, if you want that to be the case, you can establish what is called, for example, a site-to-site VPN. With this site-to-site VPN, you create, enable remote access to your VPC by creating, establishing this VPN connection and configuring some routing in both your VPC to pass traffic to your on-premises network, and you also configure routing on your own premises to pass particular traffic to your VPC. Of course, the communication is encrypted, but it goes over the internet. So we've seen about virtual private networks also before, but in this case, the important thing is here, you are trying to connect your VPC to your on-premise network. It has to go in this connection approach uses the internet, but the communication is encrypted. So in order to do that, of course, the VPC has to so what is called a virtual private gateway has to be attached to your VPC, and on the customer and on your data center, corporate data center, you have to attach what is called a customer gateway. This is what then establish the what is then used to establish this site-to-site VPN, and the route tables at this location helps to determine how to route traffic to the other network. Yeah. We also have what is called direct connect. So AWS, this is a solution to make it easy to establish a dedicated connection from your on-premise to your AWS network of VPCs. And in this case, the communication does not go through the internet so you can establish a private connectivity between your AWS and your corporate data center without the internet. Of course, it also has a higher throughput for communication, so it's faster than the site-to-site VPN. Yeah. So I show here. It's just a demonstration. So the diagram is showing that when we need communication between our corporate data center and our VPC or resources in our AWS net, the resources that we use in the AWS cloud, for example, an S3 bucket, we use what is called a public virtual interface in AWS from the direct connect, and when we want to connect to our VPC, we can use what is called a private virtual interface. More details on the differences between these will be seen as you go higher in your cloud journey. But just remember that for connecting to your VPC, you need a virtual private gateway, and for connecting to S3 to other resources in AWS, you need a public virtual interface between the direct connect and AWS, and that helps to connect your corporate data center to the resources in the cloud. You could do either a direct connection, or you could go through another partner router to be able to establish this direct connect. So you would also learn more about different types of direct connects in your cloud journey as you go further. So, but for now, just know that you can use a site-to-site VPN to connect to your VPN to connect your data center to the cloud, or you can use a direct connection to also establish a faster connection or a connection isolated from the internet. Yeah. So again, so if we've seen the several different options, we've seen these two connections that we've been mostly talking about, connecting one data center to one VPC. But what happens now if we want to connect one data center to several VPCs? Do we have to establish direct connect with all the VPCs? No, you just create a single transit gateway, and it will provide this functionality. So again, this is another role that is being played by the AWS Transit Gateway, that even for your on-premise data centers, you can immediately create a use, for example, a site-to-site connection. You create a customer gateway, and on the VPC on the AWS side, instead of having a virtual private gateway, you can, as in the case of one-to-one connection here, you can replace it with the transit gateway, and it would now be able to connect with all the other VPCs. Also, you can use direct connect and connect directly to the transit gateway, and you'll be able to now reach all the other VPCs from your on-premise data center. I hope that helps, and if you have questions, we can discuss. Thank you very much for listening.
Sergio, are there any questions, please? Or maybe let me just try to just go back a bit to where we had site-to-site VPN, because I know when we start talking networks, just to make sure, I know you explain it, but I just want to make sure that everyone, in case there are confusion, because network remains a very broad topic, right? So, so just keep in mind from this diagram, when you are site-to-site VPN, and remember virtual private networks was covered last session. So if you notice here, Tio said that you see you have an on-premises. So imagine, for example, a bank that has a data center that is on-premises network, and then imagine that same bank have gone to AWS and they have created a virtual private cloud, right? A VPC. And now they want their resources in AWS VPC to communicate in their resources that are in the data center. So you have two options. You can use the internet. So the internet, remember you have the data center and you have the VPC, all of this virtual private cloud, just because you can access when you want resources to communicate. It's different from when you log to those resources, because we know when you create a VPC on AWS, of course, you are on the internet, you can go in and manage it. But when you want resources in your data center to communicate with resources in the cloud, one option that has been provided is you use the site-to-site VPN here, as Stuart explained. So you need an internet connection here for site-to-site VPN. And of course, you need a customer gateway. A customer gateway is just here. It's another form of a router, right? That directs where traffic should go. So just keep in mind, customer gateway is just another form of a router. Virtual private gateway is also playing a function as similar to that of a router, direct where traffic should go. And on both sides, once you have them, then you create what is called a site-to-site VPN, which is just another configuration, right? And it's secure. Yeah, but it's just that it's limited in the amount of, let's say, it takes up to about 1.2 megabits, I think, of traffic, but it's limited or in terms of throughput, as Joe said. Then go to the direct connect diagram. So in the direct connect, direct connect is like, think of it as, remember in the first case, we are using the internet, right, to be able to do traffic. So direct connect is, think of it as like you really want a cable running from your data center to AWS cloud. So you want like a physical cable, right, that runs from your data center to AWS cloud. And what this happens is, we talk about AWS, and we have all learned that these are data centers, right? We've talked about regions. We have said that regions are availability zones, 2 or more availability zones. And you remember that availability zones are made of data centers, right? So 1 or more discrete data centers. So all these things always boil down to physical things you can see. You can go and see a data center. You can go and see all the routers and networks that help that data center to function. So when you want a direct connect is where you want kind of a physical cable to run from your, and when you order for direct connect, it always take longer to have it because maybe you have a telecom comes and put a cable if it's not yet available. And then we'll go to what is sometimes what is called here AWS Direct Connect location. So AWS Direct Connect location is just like it's a physical place that you can see where you have in this, I'll just simplify it to routers that are connected to AWS data centers, right? So in the AWS Direct Connect location, it's a physical location. Your customer on-premises center is also a physical location, and telecom providers in Germany, you have, for example, Telcom. In other countries, you have different names for those providers. They will help to connect the physical cable that will run from your customer network to that direct connect location. And in that direct connect location, there's also a router that connects to AWS data centers, which will maybe
Ben, we lost you. Hello. Okay. Why he's coming? If someone has a question, you can go ahead, or something to add. I see my fellow colleagues also here. So if there are any questions. Hello, can you hear me? Everyone is seemingly silent.
Yes, we can hear you.
Okay, thank you. So yeah, I think he's what happened? Okay, so let's just while Prof. Van is coming, we can look at the question. When he joins, he can go further with his explanation. But yeah, so let's look at this question about what is available in AWS that lets you provision a logically isolated section of the AWS cloud where you can launch AWS resources in a virtual network that you define. So if you have your answer, you can say it loud or you can post it in the chat. Okay, I see a lot of people going for C. Thank you all for responding. I would say, yeah, the answer is C. So as we've seen, we use a VPC to create logically isolated networks within the AWS cloud. Yeah. Okay. Okay. Ban is still not connected. So we go again to the next question. Which of the following is typically used to secure your VPC subnets? Thank you, Tatiana. Thank you, Leslie. I see that you're going for A. If other people have other opinions, it would be good to hear. Remember that the more you express yourself or your opinion, the more you have a correction to what makes you come to that conclusion, or find a way to agree on in terms of the explanation of why you came to that conclusion. Yeah. Thank you. Someone is saying NACL.
NACL control security at the subnet level, while security group controls security at the instance level. So I choose A, which controls security at the subnet level.
Thank you. I will just say thank you, Lawir. I don't know which Lawir is there, but thank you very much for that contribution. Thank you. So yes, a lot of people agree also with you in terms of the answer. I hope that the explanation was agreed upon also. So we have NACL to control, as Lawir said, security at the level of our subnets. Thank you. Okay. Which of the following is used to enable instances in the public subnet? Sorry for that. The public subnet to connect to the public internet. Remember, enable instances in the public subnet to connect to the public internet. Oh, I already see people coming with B. Well, I wonder if somebody can shoot out an explanation for that. If it's possible to come out verbally, that would be nice to hear. Or if there are other opinions, I just give you another chance to post it in the chat about the answer. So I just have 2 people would be. Does that mean that the others don't understand the question? And yeah, if you don't understand the question. Oh, thank you very much.
Yeah, because the internet gateway controls traffic through the network.
Okay. So.
Or it controls the public. It takes care of the network publicly, as you explained. Yeah.
Okay. So yes, thank you, Sally. And so we have the internet gateway as our main choice here. Okay, so there are some technical issues. Our prof cannot be able to connect again, but yeah. Did I hear another opinion, please? Okay, so for now we have B as our main choice, and as Sally have said, the internet gateway is what is in charge of connection to the internet for our VPC resources. Okay, next question. A customer needs to establish a dedicated connection between their on-premise network and their AWS VPC that provides a more consistent network experience than internet-based connection. Which of the following network services should they use? A, AWS VPN Cloud Hub, B, VPC peering, AWS Direct Connect, VPN, D is VPN connection. Somebody says, I would not say the answer loud, but thank you, Tatiana, for your answer. Can I get more support for Tatiana? C, Tatiana is saying C. So thank you, Edwin. Edwin agrees with Tatiana about the answer. Sometimes I wish there was a different opinion. I don't wish somebody to not pass or do right, but yeah, it's just always good to have varying answers. And even when you are wrong, it's nice to have somebody who has a different opinion. It just points out also more where the explanation was not clearer, and we can then be able to do better in our subsequent preparations for such lectures, yeah, or presentations. Thank you very much, Leslie. Yeah.
More interaction. Even if it's the wrong answer,
yeah, so the voice is also breaking, but I could hear you say even if it's the wrong answer, it's always right to have it and be able to use it to improve upon our explanation, if that is where you are going. Yeah. So the wrong answer is not their fault, it's our fault for not explaining right, explaining well.
Hello, I would have gone for D, but just like you said, it means I would not have understood the concept. So
no, not you. Yeah, which means
no,
we didn't explain.
I'm talking about myself, because D is also, because D could be the answer, but the right answer, to be exact, just like you explained, is the C for me.
Yeah. So why is D not correct? Because we talked about VPN connection. Why is D not correct?
It won't be, according to what I understand, it will not be correct, because the C links us directly. I don't know. I cannot really place a finger on the exact explanation. But
Let me try helping you, please.
The two could go, but I just choose.
Let's see. Okay.
Hello.
Leila will try. Yeah.
The
Thank
Z
you.
could also go, but I just.
Yeah, I think C is when AWS connect you directly with a cable from your data center, from where you are to their data center. But this one is when you are linking your data center with their own, and then I think was a different concept, which I can't get it, but I know that this cannot be the one.
Okay. Does somebody else have another opinion? I mean, look at the question, right? It says something there that can make you say exactly why one is not the right one and the other is the right one. So, of course, all of us have decided that A and B are not correct. So why is it C or why is it D? We need to pick it out from the question.
I think what get me to go for C is because it talks about a more consistent network experience than internet-based connections.
Thank you,
So
Tatiana. Yeah, go ahead.
So we are looking at direct connected because we are connecting our VPC to AWS cloud, not using any internet connection. That's why I went for C, and it also talks of more consistent network. I remember you and Mr. Banjika mentioned high throughput support when you use direct connect.
Wow.
That's why I went for this.
Thank you very much for that explanation. Thanks very much. So it's already 7:07. I think we are quite above the time, but so there are more questions there. You can look at the slides and discuss within yourself with each other. But just to give another chance, Prof. Ban is back. Maybe he can round up the session if he is able to come on voice.
Yeah, right. Thank you, Theo. Sorry, I had some technical issues and missed my connection, but I don't remember exactly where I stopped. But I think we were at Direct Connect where I was trying to talk about the cable and everything. And nice to see there's a question that comes up trying to know that. So my emphasis will be that please just when you go back, just sit back and try to look at these differences. And when you are always studying, right, you remember when we were studying, when Theo started, he did talk about VPC peering, and then after that moved to transit gateway. Now, remember, AWS have been progressing. It's not like they created all these services at once, right? So at the beginning, what you had was just VPC peering, where you could connect one VPC to another. You know, all VPCs had to be connected, but then there were drawbacks in it. There were difficulties in it. And then, of course, they sat back to look like how could they address this problem? And then AWS Transit Gateway came up. Right, but there are still reasons why people can use the VPC peering, but a much more better way with the transit gateway. So one of the things that I always say when studying is always ask yourself, like, why did this service came up? What was it trying to solve? Because when you ask that question, you may be able to understand why that service is in the first place, rather than just like maybe just looking at all the services, because AWS keep creating services and is always trying to improve on what they had. Just like we did talk about site-to-site VPN, and then of course in the very early beginning, site-to-site VPN was easy, and you've heard about it. Using the internet was very easy. But then, of course, happy to hear Kenya explaining that. So she captured that, you know, so it happens that it doesn't give more consistency. There's no throughput, but then there are possibilities to connect data centers, because at the end of the day, connecting your customer, the on-premises, which is a data center, to AWS cloud. Remember, AWS cloud is also it's also made up of data center. So you can do that using physical cables, right? So that's what I was trying to explain. So my advice is, with all these different concepts that can look many, pick one at a time, try to understand why one exists, or what is it trying to address, or how did it progress. That will structure, I think, the information better in your memory, and also you can always see the advantage or disadvantage of another. For the practitioner, I mean, just thinking more of the exam, make sure you get, like, for example, the difference between direct and site-to-site, and all those security group and NACL, right? Differences, what they are, what are the differences, understanding. I think with time, before we will surely, when we'll start doing the revision, which is happening, I think I want to congratulate all of you who have come this far, because it's just 3 more modules left, and we'll be over with the session. So we should start doing revision by end of this month, after next week, basically. So once we start that, some of these things like creating a VPC, you know, creating subnets, are some of those things that we'll always dive to once in a while, just to bring more clarity. But you have to do your own work as well to, like, try to look differently into these terminologies. There are many in the beginning, but when you pick them one by one, you start realizing that, yeah, you'll be unpacking them, and they're not as so complex as they may appear, right? It's just more of seeing something for the first time can be challenging, but it doesn't mean that if you put the effort, you'll be able to go through. Yeah. So I think that's all I can round up with, and continue to encourage all of you to be very consistent. We have a session tomorrow, and then we have 2 more, and then there will be a makeup for the data analytics that we missed, because one of our instructors actually had some family emergencies and couldn't come on board, but we're going to have that covered, so that has not been forgotten. Yeah. So that's what I could say, and yeah, I don't know. I know it's above time, but if there is something someone wants to bring up, I'll bring the survey. And again, please make sure you help us finish the survey and share your input. But if there's something someone wants to say before we go, you can do that. Let me